Hello and welcome to day 8. Day 8 for me, not for you, because it is the 16th and I am catching up. So we're going to jump right in. Day 8, handheld halting. I hope you can see a pattern here. It looks like everything is an alliteration on these days. So handheld halting. We'll see how high we go on the different letters, but for now, handheld halting. So what we've got here is we have an infinite loop in some kind of boot code, which is the input, the puzzle input, and we should be able to fix it. And it has a set of operations, one instruction per line, and we have an operation, ac, jump, or well, I'm going to say jump or nop. And an argument, assigned number like +4 or -20. So we're going to have like some kind of split, I'm assuming. Okay, so yeah, here's what this looks like. So we go nop 0, ac +1, right? So we're going to split on this white space and turn this into an integer, turn this into some sort of operation code, and then follow the operations. Now, if you did last year's, this is actually kind of representative of a little bit of what we did with the int coder, but that was all integers. Now we actually have like an operation that tells us what to do, rather on the last year it was an integer that told us which operation to do. So now we have strings for that instead of integers, which is kind of helpful. Okay, so if we follow these instructions, we don't do anything here. We have accumulator +1, which will do something with the accumulator. We have jump +4, so this will take us from this spot all the way down to here. Okay, so we go from 3 to 4. This has an accumulator. We move on to the next step, and then it has a jump -4, and we go back to here, and then this has a jump -3, which brings us to here, and this is where it fails, right? Because we're not supposed to go to the same spot, because this will just put us in an infinite loop. So in this case, yeah, so this just explains what I just walked through here in terms of all these instructions. This is an infinite loop, yeah. So immediately before the program would run an instruction a second time, the value in the accumulator is 5. Okay, so we're trying to calculate what the value in the accumulator is. 1, 4, 5, right? Or rather 1, 2, 5, because that was the last instruction run right there. Okay, and we never make it to this +6. Okay, so based on our inputs, what is the value? What value is in the accumulator at the very end? Okay, let's dive in here, dive into our code. Let's get rid of yesterday's here. Oh, what did I do? What did I do? I want to go back. Whoops. Copied the wrong thing. Okay. Okay, so here's our test code. We're going to get rid of day 7. We're going to jump into day 8. Okay. Actually, let's bring back day 7 and just copy some of the code here. Okay. Now we can get rid of day 7. Okay, because I like to have all of my part 1 and part 2s here. Okay, so now we're reading in the lines. Let's just do data here, right? And let's get rid of that. Okay. Okay, so we've got a nop, which doesn't do anything, so we can just skip that. We've got an accumulator, a jump, an accumulator, a jump, accumulator, jump. Okay, so all of those are the same. Wait, what is this -99? Accumulator -99. Great. Okay, so what we're going to do here is in part 1 we're going to have data coming in, and we're going to have our accumulator is going to be 0, and then we're going to have our processed instructions is going to be a set. Okay, and this means that we can't have any duplicates, and it will also have very fast lookups. And we can add to it pretty quickly as well. And then we'll have an index which is going to be 0, always starting with the very first line of instructions, and we'll follow through from there. And we'll say while true, and this may not be best practice. We'll have to make sure that we insert a break, or we could try and come up with some way to tell it when it needs to stop looping, but just know that we're going to try to avoid the infinite loop problem. And we're going to say that our current line is going to be data index, right? And now we can change the index. So we need to go through the instructions for, okay, how do we change the index? So if index in processed, then we can break, right? So before we do anything, let's double check whether or not we've already processed this index, and that's going to be where this processed is, right? Processed. If the index has already been processed, then we're going to break our while loop. Otherwise, we're going to say that processed, and we're going to add the index to that processed list so that we add it to the list, and then we'll run the process and everything. So remember, if we don't, the goal here is that we want to find the value in the accumulator before it goes to that same value again. So if we waited to break the process at the end of the loop, then we would actually end up running this, and we would get a value of 6 rather than 5. Yeah, so 6 rather than 5. So we need to break at the very beginning and then return the accumulator right down here. Okay. So next, we've got our instruction, and let's just call it, let's call instruction, and we have our value, and that is going to be our current dot split. Okay, so on our data here, we have this space, so we're going to split on the space, and then we'll convert this part to an integer, and we've got this as the instructions. Okay. So if instruction is accumulator, right, this one's the easiest. We just go accumulator plus equals int of the value, and we go index plus equals 1. So if the accumulator, if it's ACK, we just add to the accumulator whatever the value is, and then we go on to the next step. If the instruction is jump, then we say index plus equals int of value. Now, what's interesting here is that the int will actually parse the plus or the minus and convert this into a proper integer. Whether that's plus positive 1 or plus minus 3, it will actually handle that all by itself, which is really, really nice. And then if we have any other value, which is the NOP value, right, we're going to say index plus equals 1. And then we return the accumulator. So theoretically, even if we never broke this, we should eventually get like an index error because we'll try to access data that's outside of the index. Theoretically, unless we get caught in that infinite loop, right? But hopefully we'll catch that this was in fact in the infinite loop, and that it will break. So we've already processed that line, and so it will break. Okay, so let's test this out. We're going to try this. Okay, so 5. We did get the correct number back. So let's go to our input, which is very bright as usual. Okay, and let's throw this into our input right there, and we'll run this. Okay, 1548. Hopefully this is the right answer. Let's find out. Bam! Yes, this is the correct answer. Okay, so the correct answer, 1548, as we can see right here. We'll continue on to part 2. Okay, after some careful analysis, you believe that exactly one instruction is corrupted. Okay, so there's one instruction that is in fact wrong. Either a jump is supposed to be a NOP, or a NOP is supposed to be a jump. Yay! No accumulator instructions were harmed in the corruption of this boot code. Well, that's handy. That's nice. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. So it is supposed to end with that particular end. So it's supposed to finish when the index is the largest, right? So we get index +1, and then if we continued on to the next portion, this would actually end up with an error, right? We would end up with like a range error or a value error or something like that. Probably a range error. Index error. There we go, index error. Okay, so for example, if we go through, we have this. If I change the first instruction from NOP +0 to jump +0, it would actually create a single instruction infinite loop. So it would go from the 0th instruction back to the 0th, and it would just continue in this 0th instruction, which infinite loop, and so therefore bad. We want to find something that fulfills the requirement of going through and actually completes the program. Program will still eventually fail. However, if you change the second to last instruction from jump -4 to NOP -4, so this one, jump -4 to NOP -4, the program terminates, right? Because we are no longer jumping back, we are just moving on to the next step, which is the accumulator. After the last instruction, accumulator +6, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains the value 8. So now we need to determine what the value of the accumulator is after the program terminates successfully. So there are like two steps here. The same thing that we did last time, where we're counting up the number of accumulators that have been added or subtracted, right? We could end up with a negative number here. And we need to fix a jump or a NOP in the program itself. Okay, so what we're going to do here is we're going to create a new function that I'm just going to call run instructions. And we're going to take in the data, and we're going to have something very similar to what we had before, right? We will have a lot of this same information, but we're going to have to add in some extra checks, and then in part 2 we're going to loop through and run these instructions and then check everything, right? So let's start off with accumulator, right? This is going to be 0 here. We're going to have our processed is going to be our set, same as before, right? This is going to be very similar to what we had up above. We have our process, which is our set. Let's get rid of that pass. Index is going to be 0, while true. And if index is the length of the data, right? So if our index is the length of the data, then we can return the accumulator, right? So now we have a check for if we actually reach the final, the last instruction, or we're past the last instruction, now we can return the actual value in the accumulator. Because now we've actually fixed the loop, theoretically, right? Our current is going to be, well, this is all going to be very similar here. So let me just copy all of this. We'll just copy all of that, and we're going to make some minor modifications. If index current data index, if index in processed, we're going to return, and we're going to return 0 here. Or we could return false as well, but I'm going to just say return 0. Otherwise, we're going to add that to the index. Okay, so similar to what we had up here, right, where we would break the loop, or we could, I guess we could have also returned the accumulator there. That's actually, that would have actually been good, is if we could have just returned at that point, because we're in a function. Okay, let's see. Return index, return 0. Instruction value, process add index, accumulator jump index +1, and then we return the accumulator at the very end, assuming that we actually make it. I don't think we'll actually make it to this point, because if we've already processed the index, this will never happen. So let's just get rid of that line, and then we'll find out if we're in an infinite loop. Okay. So next, so now we've got a function that returns the value of the accumulator that's in the accumulator, or it returns 0. So I'm assuming that the result of my code will not be 0, and that 0 will not be the answer. Well, actually, let's just, because we can test that. Okay, 0 is not the answer. So we can assume that this will not in fact be 0, and we'll move on from there. Okay, so next, let's go through here, and we're going to iterate line through line of the data. So for line in range length data. So we're going to access it by index. We don't want to we don't want to iterate through the data, because we can't modify the data while we are inside the loop. So if I were to try and say something like for line in data, I can't then modify the data inside of the memory. So we're going to do for line in range length data, and then I'll say lines is data, and we're essentially making a copy here. Making a copy of the data, and then we're going to make a swap of some kind, right? If the opcode is jump, then we're going to replace it with a nop, and if the opcode is nop, we're going to replace it with a jump, and then we're going to try and run the instructions. So we're going to go through every single thing. We're going to run the instructions, and if it spits out a result of 0, then we know that that's not actually the correct answer. So we'll say if jump in lines in the particular line that we're in, right, on that particular index, then we're going to say lines equals lines line, plus we're going to have lines line dot replace jump with nop, plus the lines of line all the way to the end. Okay, I think I did that. Right. Is this supposed to be lines plus 1? It's supposed to be line plus 1 there. Yeah, because we're accessing this one, and we don't want to include that one, so we go all the way to the end. Okay, and then we're going to do something very similar here. Else, if if nop in lines line, and I'm just going to take this and copy that, and we're going to say nop, and we're going to replace it with jump. Right there. Okay, else we're going to continue, because the only other instruction is the accumulator instruction, which we will not be changing. So we won't actually have to run this, run the instructions for every single line. So we're going to have our output value, which is going to be run instructions for our lines, and if the value is greater than 0, then we can return the value, right? Otherwise, it will just continue on to the next operation and try to make the changes again. So theoretically, this will actually get us back the answer that we're looking for. We're just going through, making one swap, and then running the instructions. And if it doesn't come out to a value greater than 0, I should say does not equal 0 here, because it might not be a positive number, right? It could be a negative number, theoretically. It's probably positive, because most of the answers are positive, but we basically are just looking for a non-zero answer here. So it will make the exchange, and then it will run the instructions, and that should be everything, I think. We successfully made a copy of the data, so it won't be changing the data as we're trying to loop through. Okay. 1375. Let's see if 1375 is the correct answer. Hopefully. Bam! That is the correct answer. So there we go, day 8. Hope this was helpful. Hope this was useful. If you have any questions or comments, just leave those below the video. Feel free to like as well and share the video. Subscribe, please. It's encouraging for me to help me keep going and useful. So there we go. I don't think there's anything else. I don't think there's any real cleaning up of the code that we need to do. It's relatively simple as it is. I don't want to overcomplicate it. We have while loops, we have for loops, and we're using mostly integers and doing string replacement. So it's a relatively straightforward process. So if you do have any questions, let me know. But other than that, I'll just see you in the next video.